Hi students, today we are going to discuss about the engineering chemistry, unit 1 water chemistry, internal conditioning and reverse osmosis process. So first we are going to discuss about the internal conditioning. Another name of the internal conditioning is the internal treatment or boiler compounds. So internal conditioning means we have to treat the water inside the boiler directly adding some chemical compounds. That is called internal conditioning or internal treatment. So the added chemical compounds we are called as the boiler compounds. So it involves the removal of scale forming substance which were not completely removed in the external treatment by adding chemicals directly into the boiler. In that chemicals we are called as the boiler compounds. So this method is called internal conditioning or internal treatment process. So in that internal conditioning methods, there are different types of the methods are involved. The first one is the carbonate conditioning. What is carbonate conditioning? The scale formation can be avoided by adding sodium carbonate, that is Na2CO3, to the boiler water, so which is used only in the low pressure boilers. So the boiler can be made up of the two types. One is the high pressure boilers and the low pressure boilers. So in the carbonate conditioning only used for the low pressure boilers, the scale forming salt like calcium sulfate is converted into calcium carbonate, because we have to use the carbonate conditioning so that the calcium sulfate can be converted into the calcium carbonate. The calcium sulfate is the scale forming substance and the calcium carbonate which is easily removed by the boiling of the water because it contains the carbonate salt. So what is the reaction involved in that? So the calcium sulfate react with adding sodium carbonate Na2CO3. So the calcium react with the carbonate into the sodium carbonate to form the sodium carbonate precipitate and Na2SO4. The calcium carbonate is the sludge forming substances which can be easily removed by the boiler even at boiling. So it is the carbonate conditioning method. Okay. Now we are going to the next type of the conditioning, that is the phosphate conditioning. Phosphate means we have to add the phosphate substances like sodium phosphate. Sodium phosphate formula is the Na3PO4. Okay. The scale formation can be avoided by adding sodium phosphate substance. It is used in high pressure boilers. Carbonate conditioning which is used into the low pressure boiler, but in the phosphate conditioning which is used into the high pressure boiler. So you have to distinguish the two different boilers. The phosphate react with the calcium 2 plus or magnesium 2 plus ions. So that means that is the cations to give the soft sludge of the calcium and magnesium phosphates. So phosphate salts of the calcium and magnesium are the sludges, soft sludges. So the calcium sulfate is the scale forming substance. So the calcium sulfate present in the hot water which react with the added sodium phosphate to form the calcium phosphate Ca3PO4 twice and sodium sulfate. So in that phosphate conditioning we have to use the three types. One is the trisodium phosphate. Second one is disodium hydrogen phosphate Na2HPO4. It is the weakly alkaline used for weakly acidic water. Then third one is the sodium dihydrogen phosphate NaH2PO4, that is acidic, used in alkaline water. So generally the phosphates are used into three types. One is the trisodium phosphate which can be used for too acidic water. Then disodium hydrogen phosphate is used for the weakly acidic water. Then sodium dihydrogen phosphate which is used to alkaline water. So based on the pH range of the boiler water, we have to use the different types of the phosphate conditioning methods in the internal treatment conditioning. Okay. So the phosphate conditioning is the very good method for the suitable high pressure boilers. Okay. Then we are going to the next conditioning method, that is the Calgon conditioning. Okay, Calgon. What is Calgon? Calgon is the coordination complex. So Calgon is the sodium hexametaphosphate. So generally we have to call it as the Calgon. So the chemical formula for the Calgon is Na2 Na4 PO3 6 times. Hexametaphosphate. Hexa means 6. So here 6 phosphates are available, so that it is called as the hexametaphosphate. Here sodium is called as the central metal atom. So PO3 is the ligand. So it is called as the sodium hexametaphosphate. So the substance interacts with the calcium ions, forming a highly soluble complex, and thus prevents the precipitation of scale forming salt. So here calcium sulfate is the scale forming substance. By adding the calgon like sodium hexametaphosphate, the sodium ions, 4 sodium ions are replaced by 2 calcium atom. So to form the Na2 Ca2 PO3 6 times precipitate, which is easily removed from the boiler. So then to form the 2 Na2 SO4 sulfate, which is easily removed from the boiler. So here we have to convert the scale forming substance into the highly soluble complex like the calcium hexametaphosphate. So this is called as the Calgon conditioning. It is very, very important. Then colloidal conditioning. Colloidal conditioning is the another suitable method for the internal treatment. The scale formation can be avoided by adding colloidal conditioning agents like kerosene, agar-agar, gelatin, etc. It is used in low pressure boilers. Okay. So in the low pressure boilers we have to use the colloidal conditioning. The main chemical compounds or boiler compounds here used to kerosene, agar-agar, gelatin in the boiler. So these colloidal substances get coated over the scale forming particles and convert them into non-adherent and loose precipitate inside the boiler. So the adherent coating, that is the scale formation substance like calcium sulfate, can be converted into the loose precipitate by adding these chemical compounds like kerosene, agar-agar, gelatin. So which is converted into the loose precipitate or non-adherent substances called as sludge, which can be removed by blow down operation. Blow down operation means by adding the fresh water into the impurity water to convert into the scale into sludge. That means high concentrated water can be converted into the low concentrated water. That is called as the blow down operation. Okay. Okay, next last condition is the sodium aluminate conditioning. Sodium aluminate is the suitable internal treatment compound, so which is used to the directly inside the boiler. So scale formation can be removed by adding sodium aluminate to the boiler water. The sodium aluminate undergoes hydrolysis to give the white precipitate of aluminum hydroxide and sodium hydroxide. In that aluminum hydroxide, which is easily dissolved in the water, which can be easily removed from the boiler based on the blow down operation methods. Okay, so sodium aluminate conditioning reaction NaAlO2, that is the sodium aluminate, react with the boiler water to form the AlOH thrice, that is the aluminum trihydroxide precipitate, and NaOH. Okay, so till now we have discussed in the 5 different conditioning methods, that is the internal conditioning of the boiler feed water. Each conditioning asks in the 2 more questions, so you have to thoroughly prepare the each conditioning. First one is the carbonate conditioning, then phosphate conditioning, then calgon conditioning, then colloidal conditioning, then last one is the sodium aluminate conditioning. So the different conditioning methods are used into the different pressuring boilers. Some of the conditionings are used into the low pressure boilers, and some of the conditioning methods we have to use the high pressure boilers. So based on the chemical compounds, the reactions are varied with varied reactions. The most important one is the calgon conditioning. So the calgon conditioning is the sodium hexametaphosphate. So in that calgon conditioning is the complexometric titration. So the Na2 Na4 was PO3 6 times, which can be converted into the calcium hexametaphosphate, which is easily soluble substance. So very very important one is the Calgon conditioning. So you have to thoroughly prepare the Calgon conditioning. And generally, as the 8 mark question, internal conditioning, you have to write the all the conditioning methods. So each conditioning methods are the 2 mark questions. So individually, they will ask into the 2 mark question. You have to prepare the thoroughly in the 2 mark question. So these are the internal conditioning methods. Now we are going to the next topic, that is desalination of brackish water. What is desalination? Removal of the common salt from the water is called as the desalination. Removal of the salt. The process of removing common salt, that is called as the sodium chloride, from the water is known as the desalination. Okay. So the water containing dissolved salts with a peculiarly salty or brackish taste is called as the brackish water. Brackish water means the salt which given the some peculiar taste, that is called as the brackish. Brackish means salt content in the water generally. So in that brackish water having the more than 1000 but less than 35,000 ppm of the dissolved salts. So based on the dissolved salts content in the water, we have to classify into 3 types. One is the fresh water, second one is the brackish water, then third one is the sea water. So in the fresh water contains less than 1000 ppm of the dissolved salts. What is dissolved salts? What are all the salts or solids dissolved in the water, that is called dissolved salts or dissolved solids. Okay. Suppose in the brackish water, the range of the dissolved salts in between the 1000 to 35,000, that is called brackish water. Greater than 35,000 ppm of the dissolved salts contained in that water is called as the sea water, marine water or ocean water. So these are all the 3 types of the water content in our environment. Okay. Then desalination is carried out by either the reverse osmosis or electrodialysis method. The most common methods we have to use in the removal of the salt is reverse osmosis method. So the reverse osmosis method is the simply method, the low cost method. So that we have to commonly used in this method, reverse osmosis. So the reverse osmosis we are called generally RO. RO means reverse osmosis. So what is reverse osmosis? So before going to the reverse osmosis, first we know the meaning of osmosis. Okay. When 2 solutions of different concentrations are separated by the semi-permeable membrane, that is the first point. What is solvent? What is solute? When the solution containing the larger amount is called as the solvent, very low amount is called as the solute. So solute plus solvent we are called as the solutions. So here we have to use the 2 different solutions. One is the higher concentration solution, another one is the lower concentration solution. So the 2 different concentration solutions are separated by the semi-permeable membrane. Semi-permeable membrane means it is the absorbing the unwanted impurities, salt content in the water. So that is called as the semi-permeable membrane. So the examples of the semi-permeable membranes I will give the later in this topic. Okay. So before going to the reverse osmosis, first we know the what is the meaning of osmosis. The solvent means generally we are called as the water. Generally the water flows from a region of lower concentration to higher concentration, that is called as the osmosis. So the solvent flow from lower concentration to higher concentration. First, what is the meaning of concentration? Concentration means how much amount of the salt content in the water or any type of the solvent, that is called as the concentration. If the salt is dissolved in the solvent is higher the amount, they are called as the high concentration. Suppose if the salt dissolved in that solvent or water is very lower amount, that is called as the lower concentration. So the concentration means amount of salt present in the solvent or amount of salt present in the water, that is called as a concentration. So that generally the water or solvent flow from lower concentration side to higher concentration side, that is called as the osmosis. Okay, now you have to understand the osmosis. Yes, osmosis means low to high concentration, that is called as the osmosis, low concentration to high concentration. Suppose we have to given the driving force in this phenomena is called as the osmotic pressure. Driving force is the externally given pressure. So we have to externally give the driving force into the phenomena, that is called as the osmotic pressure. The excess of osmotic pressure is applied on the higher concentration side. Okay, the solvent flow from higher concentration to lower concentration. This process is known as reverse osmosis. So see the diagram. So in this diagram, the central we have to separate at the two different concentration by using the semi-permeable membrane. So left side is the saline water, then right side is the fresh water. Generally fresh water is the low concentration. You know very well, fresh water containing the low concentration. Low concentration means the amount of salt dissolved in the water is very low or zero concentration. So that is called as the fresh water. Then the left side inside of the piston having the saline water. Saline means salt water or sea water. So sea water is generally we are called as the more amount of the salt. So the more salt dissolved in that water is called as the high concentration. So saline water is the high concentration, fresh water having the lower concentration. So the direction of the low concentration to higher concentration is called as the osmosis. So that is the direction of osmosis. Osmosis means the movementation of the solvent from lower concentration to higher concentration side. That means fresh water to saline water side. It is called as the osmosis. So generally osmosis means low concentration to high concentration side. Now we have to apply the hydrostatic pressure, that is osmotic pressure or external driving force from the higher concentration side, that means saline water side, with the help of piston. With the help of piston we have to given the hydrostatic pressure from the saline water side, that means higher concentration side. Now the solvent flow is reversed through the semi-permeable membrane. Now the solvent move from higher concentration side to lower concentration side, that is called as the reverse osmosis. So the process of reverse osmosis, pure water is separate from the saline water or salt water. This process is known as superfiltration. Once again I repeat, by applying the hydrostatic pressure or external force by using the driving force with the help of piston, now the solvent flow is reversed. That means the solvent flow from higher concentration side, that means saline water side, into lower concentration side, that is called as the reverse osmosis. The commonly used membrane here, semi-permeable membrane. The semi-permeable membrane function is which absorb all the unwanted impurities, that means salt content from the water. For example, calcium, magnesium, chloride, sulfate, sodium, etc. Any type of the salt which easily absorb the membrane. So in that membranes containing small holes like nature, in that small holes like nature which absorb the positive and negative, that means cations and anions present in the water. So the water purified, this method is called as the superfiltration. The most commonly used semi-permeable membranes are the cellulose acetate and cellulose butyrate. That is the example for semi-permeable membrane. Okay. Once again I repeat the process of the reverse osmosis. So the reverse osmosis, before going to the reverse osmosis method, we have to remove the common salt. It is called as the desalination. So in the desalination process, we have to carried out by the saline water is converted into the fresh water. The water can be classified into three types based on the dissolved salt content in that water. First one is the fresh water, another one is the brackish water, then sea water. So sea water is greater than 35,000 ppm dissolved salts content is called as the sea water. Suppose the water dissolved salts in the range of the 1000 to 35,000, that is called as the brackish water. It is the peculiar taste, and less than 1000 ppm salt in the water is called as the fresh water. So in reverse osmosis method, we have to generally used into the sea water into the fresh water. So here we have to use into the semi-permeable membrane. The two different concentrations are separated by the semi-permeable membrane. In the two different concentration solutions we are called as the one is the higher concentration, another one is the lower concentration. So generally the water flow from lower concentration to higher concentration is called as the osmosis process. Lower concentration means fresh water, and higher concentration means that is the sea water. So normally in generally the river water is mingled with the sea water. The river water is called as the lower concentration, and the sea water is called as the higher concentration. In this process we are called as the osmosis. Okay, osmosis means the solvent flow from lower concentration side into higher concentration side. Now we have to use as the reverse osmosis method. So now we have to this reaction can be reversed by using some external force. External force means we have to given the some extra pressure from a higher concentration side. So the higher concentration side we have to use the pressure using the piston. Now the solvent flow is reversed. That means higher concentration side to lower concentration side, the water is flowed. So in that semi-permeable membranes containing some minute holes, in that minute holes act as the absorption process. So it minute holes membranes absorb the all the types of the salt content in the sea water. For example, calcium, magnesium 2 plus, calcium 2 plus, K plus, Na plus, Cl minus, CO3 2 minus, HCO3 minus, then SO4 2 minus, any type of the anions and the cations available in the water, that all the cations and anions are absorbed by the membrane. Okay, the common membranes used in this method is the cellulose acetate and cellulose butyrate. So the cellulose acetate and cellulose butyrate are the very good examples for the semi-permeable membrane. So the water purified from this method we are called as the superfiltration. Superfiltration means the water, fresh water, it should be free from the all the cations and all the anions, so that it is called as the superfiltration. So at one particular stage the membranes are not working because all the salt contents are absorbed in that pores or holes. At one particular stage there is no process will occur. So we have to frequently exchange the semi-permeable membrane. That is the disadvantage of this method. So after the exchange the semi-permeable membrane only, again the reverse osmosis process will continuously occur in the process. Okay. So you know the what are the mechanism, what are the various steps involved in the reverse osmosis. Okay. Now we are going to the some advantages of the reverse osmosis process. What is the advantage? The lifetime of the membrane is very high and it can be replaced within few minutes. So here we have to use the generally semi-permeable membrane, that is called as the cellulose acetate and cellulose butyrate. The cellulose acetate and the cellulose butyrate is the commonly used semi-permeable membrane. The lifetime is very high and it can be replaced within the few minutes. That is the first advantage of the reverse osmosis method. Then second advantage, It removes ionic as well as non-ionic substances. Ionic means positive ions and negative ions. For example, calcium sulfate. Calcium is the cation, sulfate is the anion. Same thing like is the magnesium chloride. Magnesium is the cation, chloride is the anion. Calcium carbonate. Calcium is the positive ion, that is the cation. Carbonate is the negative ion. So likewise, we all have to remove the all types of ionic substances, both cationic and anionic substances removed from this method. And non-ionic means like sugar like substances, C6H12O6, carbohydrate, then turbidity content in the water, different salinity. So all the non-ionic like substances and colloidal impurities also we have to remove in this method. But in the ionic exchange process, only we have to remove the cations and anions, but turbidity water, water containing the Fe ion and manganese is not suitable for that method. But in this method we have to use into the colloidal impurities also removed from this process. So and then the process is used for converting sea water into drinking water. So the seawater means the water containing the more than 35,000 dissolved salts in the solvent. So in all the types of the dissolved salts are absorbing by this process. So it is the very suitable method to seawater converted into the drinking water. So these are all the some of the main advantages of the reverse osmosis process. The first one is the membrane lifetime is very high. Then it can be replaced by the few minutes, within the few minutes. Then ionic as well as non-ionic substance can be removed from water from this process. Then the colloidal impurities also removed by this process. Then important one is conversion of the seawater into the drinking water is the main advantage. So these are some of the main advantages of the reverse osmosis. Okay. Next, what are all the disadvantages of the reverse osmosis method? The disadvantages of the method is the high cost method, because the membrane cost is very very high. Cellulose acetate and cellulose butyrate rate is very very high, so the expensive is very very high, so that it is called as the high cost method, because we have to treat the sea water into drinking water. So it is the high cost method. That is the main disadvantages. Then another one is the maintenance is very very difficult. Why the maintenance is very very difficult? We have to use the seawater. In that seawater containing the more amount of the salt content, impurities, colloidal nature, iron content, Fe content, calcium, magnesium. So most of the unwanted impurities are available in the seawater, so that it remove the or it damaged the semi permeable membrane frequently, so that the maintenance is very very difficult. So these are all the various different types of the disadvantages of the reverse osmosis method. So with this topic we have to wind up the today's session. So in the today's session we are discussed about the internal treatment of the water. Internal treatment means softening method. The internal method we have to discuss in the 5 different conditioning methods. What are the 5 different conditioning methods? One is the carbonate conditioning, then second one is the phosphate conditioning, then calgon conditioning, then colloidal conditioning, then last one is the sodium aluminate conditioning. So in that all conditioning methods we have to remove the scale forming substance into the easily water soluble compounds. Some of the conditioning methods we have to use in the high pressure boilers. Some of the methods we have to use in the low pressure boilers. So internal conditioning method is the one of the important 8-mark question. Another important question is the reverse osmosis. So the reverse osmosis process, the external treatment process. So before the water feed into the boiler, we have to remove all types of the impurities from the water. So this reverse osmosis method is commonly used for the removing of table salt like the common salt. NaCl also we have to remove from the water. So in this method we have to use it into the sea water is converted into the drinking water. So in this method we have to use the semi-permeable membrane. In that semi-permeable membrane cost is very high. That is the disadvantage. Okay. So thoroughly you have to prepare these two questions. The two questions will ask the frequent in the university examination. So you have to thoroughly prepare. You have to give them more writing practice. All the best. Thank you.